Okay, we're picking up geometry, and this time we're going to talk about angles, okay? Last time we talked about lines, rays, endpoints, all that good stuff. Today we're talking about angles, okay? We're going to be able to draw points, lines, line segments, rays, all different kinds of angles. Let's get right into it, okay? Let's add some new definitions to our geometry journal. So if you don't have your journal with you, go ahead and just write it down on a piece of paper, bring it tomorrow. Parallel lines, okay? Lines that never intersect and are always the same distance apart. Okay? Now I'm going to keep going through this pretty quickly. You can, of course, pause your video, go back and play it again if you need to write these down. Okay? These are what parallel lines look like. Okay? They are lines that go on and on and on in both directions. But look, these lines never bend, they never twist, they never turn, they never run into each other. Okay? If you picture a door, both sides of the door, if they were lines that kept going in both directions, they would never cross and make an X or a cross or anything like that. They just go on and on without ever touching. Those are parallel lines. Let's do another one. Perpendicular lines. Okay? They are lines that form four right angles. Well, we're going to see what right angles are today. Four right angles. I thought I lost my winning ring. Sorry. Lines that form four right angles. So, a right angle is a 90 degree. And one thing, and we'll get to it, but if you can put that little perfectly square box, that's a 90-degree angle. Same thing there, same thing there, same thing there. Okay? A really well written out T or a cross would give you perpendicular lines. Okay? Okay, what is an angle? Let's talk about that. An angle is made up by two rays, okay, that have the same endpoint. The endpoint is called the vertex. So you see here that we have one endpoint, and then off of that endpoint, there's a ray that's going on and on and on this way, and then here's a ray that goes on and on and on this way, okay? That endpoint that they both share is called the vertex. Let's get out and explore with our protractors a little bit, okay? We're going to do a little bit more of this in class, but when you have, let's see if this even works. Okay. When you have, we'll just play with the pin here. When you have your protractor, okay, these are all angles. And you can kind of think about it as you have your vertex, which is always going to be right in the middle, and that's why there's that little blank spot in your protractor, okay? And then if you were going to put this over a line, you always want the line to line up here, and then let's just say, for example, the other ray from the vertex was going right here. Well, you can look at this, and it's not the best line, okay, it's freehand, but you can see if this is 0, 10, 20, 30, 40, 50, 60, that's 70, so that's about 61. And what we do is we call that 61 degrees, okay? So we go from 0 to 61 degrees, all right? We're gonna talk a lot more about these. I'm not going to spend as much time on that because we're going to actually do them in class because I think they're better off to look at those when they're in your hand, okay? There are three types of angles. Okay. A right angle makes a square corner, like the edge of a piece of paper. Okay? Just like we talked about earlier. All right? An acute angle is less than a right angle. So if I have the same vertex, I've got a line here, an acute angle would be smaller. So something like this. You see that this line doesn't quite make it up to the 90 degrees, okay, or to the right angle. So it's that angle right there. Our last angle that you will need to know is an obtuse angle, which is greater than 90 degrees. So if I still have that same vertex, my other ray would be larger than 90 degrees. Okay? So right angle, acute angle, obtuse angle. Okay? Here's some examples. Right angle, you see, perfectly 90 degrees. Now, does 91 degrees or 89 degrees look a lot different than 90? No, but that's why we use our protractor, okay? And acute angle, it's that cute little angle. It's real small, okay? Kind of like a cute little kitten, all right? And the obtuse angle, really big, bigger than 90 degrees. Skip this, we'll do that in class, okay? Oh, spoiler alert. Okay, again, same thing here. Let's see if it works this time. Maybe not. Let's go through a couple things, all right? We can see angles using our protractor. Okay, so if I wanted to find an acute angle, or excuse me, a right angle, I would put my vertex right in the middle. I know that this line is lined up with 0, and I would need to come down from 90. That's a perfectly right angle. Okay, What about 45 degrees? Where would 45 degrees be? Well, 45 degrees is right here. If I bring that down here, this angle right here, smaller than 90, doesn't make it to 90, so that's an acute angle. Okay, what about 110 degrees? Well, let's do the same thing. Same vertex, come down from 110, but check it out. That is way bigger than 90 degrees, so that is obtuse. Okay? Have those definitions. We're going to play with our protractors a lot more in class, and I'll see you then.